Good evening, everybody. I am, for my discussion, going to argue in favor of a thicker information system architecture in terms of software, so more computing happening on the client side. There's a couple of reasons that I'd argue in favor of this. The first one is because hardware costs. So to actually perform lots of computing, you need hardware that can handle that, and hardware costs have come down a lot, not even just kind of year over year, but certainly decades. Think about how much computers cost in the 80s and 90s. So while there's more computing that needs to happen, hardware is keeping up with that and coming down. You look at a lot of high schools where laptops are becoming kind of one per student. Sort of becoming standard to have some pretty basic computing power on hand all the time. From our lecture, we talked about smartphones as another good example of that. So you no longer have to be a huge major corporation that can invest millions or billions of dollars into IT in order to have top-notch on-site computing powers. Pretty easy to handle on-site. Another example of that would be a lot of small businesses that are using iPads as cash registers, and kind of they handle all of the point of sale. I've gone to barbershops and coffee shops, and we've all been to a lot of shops where you just have that white iPad that spins around, and you can sign your name just like that. So for under $400, you can get an iPad and Apple's ShopKeep, and you have a full point of sale system. You just need to pay for internet, essentially. The other reason I would argue for a thicker architecture with more client-side processing is in case of any kind of outage with the server or with connections to that server, you're able to continue more business processes. Maybe not all, but at least more than if there was more computing power on the server side. An example from that actually would be I work for a bank, and our teller platform is in constant communication with every transaction, and lots of information at your fingertips at your computer, so actually at your station. But in case of an outage with the server or a connection to that server, our teller platform can switch into what we call no host mode, and you're able to continue business processes with minimal customer impact. And you can imagine if it was flipped the other way, being in the situation where you just have to tell customers, sorry, I can't help you. Have a good day. So the more you can do on site, of course, the more you're less you're open to stopping business just because of an outage. And then discussing the role of a server side and a client side programming, I looked at it more from today's informational systems. Maybe not, it's kind of a big topic and hard to really talk about in 5 minutes or less. So if you just look at it today, the way you view most people's server-side programming, it's mostly just to store large amounts of data, and then also to verify credentials and access. So if you need information on a server, that server is going to verify access, but also that's where you're going to see large amounts of data. The one exception to that you see a lot is cloud computing, of course, which is going to be almost solely done on a server. So that's how I view most server-side programming in today's society. And then on client side, it's really down to actual functionality, again, with the exception of cloud computing. Things like apps and programs, Microsoft Office, although, again, even that's going towards cloud with the Office 365. But a lot of your actual functionality, you think about business data analytics, and any software that has a functionality. The camera I'm using right now, of course, is going to be local on the client side. So what we think of as day-to-day actual software, again, not including cloud computing, that's going to be the role of the client side. So there you go. Thicker architecture for the win. Thank you.